going to discuss a topic called multiplexers. Mainly, it comes under digital system design subject with a VHDL code. The name, the VHDL, the full form is Hardware Description Language. So mainly the multiplexer we normally call as MUX is a combinational circuit. That is, it is selecting many inputs and it is giving only one input. That means it is mainly act as a data selector, because we are having so much tons and tons of data, and the multiplexer we can use to get a particular data that we want, that using, and it mainly controlled by select lines. So it is mainly used for routing the calls. This is the block diagram of a multiplexer. Here we are having 2 power n input data lines. If we give 2 power n input lines to a multiplexer, it will give only the output data line that we require with n number of select lines. So here for 2 power n input lines, n selections, we are getting a single output data line. So it is also called as many to one circuit or n to 1 selectors, etc. So it is mainly used to increase the amount of data that can be sent over a network within a certain amount of time. There are many types of multiplexers, that is 2 by 1 MUX, we generally call it as 2:1 MUX, and 4 by 1 means 4:1, or 8 by 1 means 8:1. That is, we are having 2 inputs and getting 1 output. Okay, 2 inputs with the help of 1 select line, we are getting 1 output. And coming to the 4:1 MUX, we are having 4 inputs, 2 select lines and 1 output. The main aim in this multiplexer is to get a 1 output. Similarly, in 8:1 MUX, if we are giving the 8 inputs, we are getting only the 1 output. Here, the number of select lines, how can we know the number of select lines? Means in 2 power n, n is defining the select line, means 2 by 1 means it's 2 power 1. So we are using 1 select line. So like that, the 4 can be written as 2 square. The square indicates the select lines. That's why we are using 2 select lines. And coming to the 8:1 MUX, 8 can be written as 2 cube. So we are using 3 select lines here. That's why we can also use 16 by 1, 32 by 1, etc. using these basic multiplexers. This is the main VHDL code. It is a hardware description language. That means it's a hardware, not like software like Python, Java, nothing like that. It's only for hardware description language to describe the electronics in components like MUX, demux, decoders, encoders, and etc. So mainly it is a code to describe a truth table of the MUX. So here in a port, we are defining the inputs. In STD logic means we are defining the input. S means this, like S0, S1, 1 down to 0 means we are using only 2 bits. So that's why we are using 1 down to 0. At the same time, if we want to use 3 bits, then we can write 2 down to 0, or 4 bits, 3 down to 0, etc. 2, 4, 8, and etc. We can take the bus. It called as bus. We can take the bits here. Y will be an output to us. That's why we wrote here out STD logic. We can end our entity. And now architecture. Generally architecture means a shape or a structure. So from here architecture, we are getting deeper or main program of the 4 by 1 MUX. So here we are taking a case like switch, loops, and etc. So from here we can say if the input 0 0, so we'll get output as I0 or I0. That's with the help of this truth table we are defining here when S is 0 0, Y will be I0. Similarly, when S is 0 1, from the truth table what are we getting? The output is I1. So with the 0 1, the Y will be I1. Similarly, 1 0 we are giving, output will be I2. Means if we want I1 line or I1, we are giving only 0 1. So if we give multiple inputs, we'll not get multiple outputs, right? We'll get only one output. That is our requirement. So if we give 1 1 also, that is 1 1, the I3 point or I3 port will be on. So I3. So when others, if we give 0 0 0 0 1 or 3 bits 0 0 0 or 1 1 1 or other numbers other than 0 and 1, will get as 0. Here the output will be 0. So we'll end this case, we'll end this process and end this architecture. Okay. So final equation means, how are we getting this equation means, 0 is indicating a bar, right? 0 is indicating a bar. So here we write S0 bar, S1 bar and I0 plus here S0 bar. 1 means S1 as it is, S0 bar, S1, then we are getting I1. Similarly, S0, S1 bar, I2, S0, S1, I3. So through this truth table, we are getting a final equation for this 4:1 mux. So to get an output, we'll run this code mainly in a Xilinx software. So ISE design suite 14.1 Xilinx software. After giving a code and running the code, and it will check the errors for it, and if there are no errors, it will mainly take to a other page in which we are going to give our inputs and get our output. So we'll force the constants, means we'll give 0 0 0 1 1 0 and 1 1 whatever we need. So if we give 0 1 to that, we get an output as I1, means it will be on. Only one output will be given, and if we take the input as 1 1, we'll get the output as I3, etc. And this is mainly the VHDL code for 8:1 mux. Similar to the 4:1 mux, we are taking 8 inputs and getting only one output. Similar to 4:1 mux, we are taking an entity port. In port, we are giving I0 to I7, that is 8 numbers, and S means our select lines. We are calling this as select lines. So why? As usually, it is mainly used to define the output. So we are ending the entity and we are starting an architecture in this code. So we are also taking a case. Here the enable bit means, if the enable is nothing but like a switch. If we switch off the circuit, there will be no outputs or nothing. So if E is on or E is 1 only, the inputs and outputs we will get. So if the E is 1, then only the circuit will be on. So when we give 0 0 0, the output will be I0 from this truth table. So same 0 0 1 will get I1. Similarly, if we get 1 1 1, the output will be I7. So if we give other numbers other than 0 and 1 or other numbers from this table, we'll get as 0 as usual. So we'll end the case, we'll end the process and end the behavior. Mainly we should check, or we should be very much careful with these semicolons. The line will be ended only with a semicolon, otherwise it will show an error. So up to now we have discussed about 4:1 mux, 8:1 mux, their types and the VHDL code for the muxes. We have only discussed the mux. Up to digital electronics, we'll only learn about multiplexers, demux, encoders, decoders. That's the theory. So mainly in this digital system design, we are also solving problems. Okay. So if they are given a problem from the function given sum of 1 3 5 6 with a multiplexer, they want to implement the function with a multiplexer. So A, B, C 3 bits, that is 2 cube. 2 cube means 8. That's why we are taking the min terms from 0 to 7. So we are using 0 0 0 0 1, like 8 4 and 1, same we have already known. And the function means they have already given 1 3 5 and 6. So the 1 3 5 and 6 will be high and others are 0. Okay. This after seeing the question, we are able to write the table, truth table. After that, mainly they have used B and C as select lines. So here we are using the other one, A, as a data input line. We are taking the A as an input line. So we have taken A bar and A. So A bar we have already known, bar itself indicating a 0 and A means 1. So A bar means it is 0. So in this truth table, 0 are present in from 0 to 3. So we have written the numbers from 0, 1, 2, 3. So ones are from 4, 5, 6 and 7. So 4, 5, 6, 7 numbers are written in this A. Zeros are written in A bar, ones are written in A. So now if we see vertically, up to now we have seen only horizontally and we written the numbers from the using the truth table. So from now we should see vertically. That means there are no circles. These circles mainly indicates what? Our question itself. 1, 3, 5 and 6 we have circled 1, 3, 5 and 6. So if we see vertically, it will be 0. There are no circles. That's why the output is 0. These are two circles. Two circles are filled. So it's 1. So the circle is filled only for A. So that's why we wrote A. This is only for A bar. That's why we wrote A bar. So coming to a circuit, how to design a combinational circuit for this question means we are writing a marks using I0, I1, I2, I3 outputs from here. So we have already known for I0 we got 0. For I1 we got 1 and I2, A bar and everything. Similarly, here we have seen A bar, A, B, C with 1, 2, 4 and 5. Same question. Means in a similar way we should write. We have already known that 3A, B, C means 2 cube and 8 bits. So here we are writing 0 to 7. And the question is saying to find the function for 1, 2, 4 and 5. So we have on only 1, 2, 4 and 5. So from here we have wrote they are taken only A, B as select line. So we are using the data input line for C. C bar and C. And from this truth table we have known that C is 0 for 0, 2, 4 and 6. That means for even numbers. So we should write the even numbers from this truth table in a horizontal way, and the uneven that means odd numbers, that is 1, 3, 5 and 7 in C line. So we have what we should circle here, only the question, the given question we can circle here 1, 2, 4 and 5. Here only C is circled, C. Only C bar is circled, that's why output is C bar. So only both are circled, that's why 1. On no circle, that's why 0. So we can draw the circuit using this. So for I0 it is C, I1 it is C bar. C bar means we can write the bar with the help of a NOT gate. So I2 for 1 and I3 0. So up to now we have discussed what is mux, types of mux and the VHDL code, how to implement a mux using a VHDL code for 4x1 and 8x1. And we have already we have also seen the problems, how to solve problems if the given a function to solve with a multiplexer. So coming to the applications, where can we use the multiplexers means it is mainly used in data routing. Means it is mainly used to connect our data or voice calls, and it's mainly used to implement the Boolean functions and in communication systems and in arithmetic circuits. And multiplexers, why we should use multiplexers means in a tons and tons of data with our requirement or our desirement, or if what we require means only single output. So multiplexer is a great option to use. So these are mainly components and digital design, and VHDL mainly is to easily modeling and simulation. And it can be also used for higher order multiplexers. Up to now we have seen only for 4x1 and 8x1, and multiplexers can be used for 16x1, 13x1 and so on. And it is used mainly for efficient hardware utilization, because this is not a software language, it is a hardware language. So this VHDL code is mainly used to determine the multiplexers, demux, encoders and etc. And we can also determine or simulate the logic gates also. Thank you.